families of thought processes. Sometimes, and I'll slip into that, I'll talk about intuition versus reasoning, but I prefer the rather neutral label, System 1, which is the intuitive system, and System 2, which is the other system. And System 1 is the one that detected that this lady was angry, and it clearly operates extremely quickly. Although in some cases intuitions can develop slowly, but the characteristic of System 1 is very high speed. System 2 is slow. The other aspect of it is that you didn't really have a choice in seeing that woman as angry. You had a choice about whether or not to compute 17 times 24. I think very few of you actually did. So, you just didn't do it, and then nothing happened. But you didn't have to do anything in order to see the woman as angry. So one mechanism is automatic, and the other is voluntary. It happens if you want it to happen. You can start and end without finishing. You can stop in the middle. So it's control as against automatic. Now, there are many computations, mental computations, that have this character, that they are performed automatically. Amos Tversky and I call them natural assessments. And, when you look around you, you make a lot of these natural assessments. You perceive objects around you, you identify them, you know how far they are from you, you know how large they are, you know their color. You don't have to think about any of this. These are all computations, and some of them are quite complex. But these are computations that the mind performs and just delivers the results to our consciousness without our being aware that we're engaging in any activity. But there are natural assessments which are conceptual. So, if I mention, it's an old example, as you'll see. So if I mention that Woody Allen parents actually wanted him to be a dentist. Now, a few years ago, this would have brought some laughter, actually. Woody Allen is no longer quite as important a figure as he was. But whatever Woody Allen is, when you hear that sentence, if you know about Woody Allen, you know that he's not going to be a very good dentist. And that computation is performed immediately and automatically. That is, we have those two components of a sentence, and we perform an operation that links them and compares them and comes out with a result. This is a good fit. This is not a good fit. And in some cases, a fit that is not good in a particular way will bring a smile. There are many conceptual analyses that we perform, on what we hear and what we see, without actually intending to do so. We are constantly on the lookout for causal connections. So if we hear and see events that are related in particular ways, we look for cause and effect, and we do that automatically. We evaluate similarity, as in the Woody Allen and dentist case. We evaluate familiarity and surprise. And very importantly, we evaluate emotion. That is, we have an ongoing evaluation, emotional evaluation of the world as good or bad, threatening or benign. That goes on automatically, and we can prove that it goes on automatically. But not everything gets computed, so there are certain aspects of the environment that don't get computed. For example, if we show this for a fraction of a second, you will have seen, or would have seen in a fraction of a second, several things. You would have seen that two of these objects are more similar to each other than they are to the third one. And here is something you wouldn't have seen. You would not have seen that there is the same number of blocks in figure 2b as in figure 2a. So, it's there, and, for a computer, if you program the computer to do this, it would be no trick at all to take that information and it would be there. Or that you could construct a tower, that if you constructed a tower from the blocks on 2b, it would be as tall as the tower of 2a. We don't compute that. So we don't compute everything that we could, and that is, it turns out, quite important. So here is a set of lines. It's actually, and now here is a computation that it turns out from recent research, actually, by Anne Treisman and my wife, and among others, it turns out there is a computation that everybody performs instantly and effortlessly. And that computation is, you get an impression of the average length of the lines in this display. You get that for free. You don't have to work at it. You can do this while thinking of something else. It's a computation that the mind is set to perform. But now there is something else that you could ask about and that we don't compute. What is the total length of the lines in this display? You have no idea. You can do it, but system 2 will have to do it. That is, you can estimate the average length, you can assess or in fact get an impression of the number of lines, and then you can multiply. Again, actually if a computer were programmed to do this, the computer would take the sum as on its way to getting the average. It turns out we have machinery that can compute the average, but we don't know the sum. If we want to have the sum, we need to compute it. That turns out to be quite important, this distinction between assessments that are natural and assessments that are not natural, and that need to be performed by system 2. That is an important distinction that we'll get back to. Now, let me show you another example of what we call the automaticity of operations of system 1. What you have to do here is, and you can humor me, you can say it aloud. I'm going to show you some objects and say the color of the objects in the following slides. Okay, so, thank you. Okay. This is one of the classic experiments in psychology. You had no control over what happened to you here. That is, the reading was automatic, and reading, it turns out, calling out the colors was not hard, but it's not something that comes very, very easily. There is a little more effort in calling out the colors than in reading. When you present the two, the reading comes out automatically, and it preempts the response. So that's an example of an automatic response. So here's another characteristic of those two systems. You can come to the Heathrow Airport in London and you want to rent a car, and they give you the keys, and they tell you, please remember that we drive on the left here. And you do, mostly. I mean, if you're not very tired, or if you can do it. That ability to adopt a rule and follow it, that is a system 2 operation. We can reset ourselves. System 1, which is automatic, is much harder to control. And indeed, when you get very busy and very preoccupied, you may find yourself driving on the wrong side in London, because you're not, well, not in London, but on a highway, because you're not actually monitoring closely enough what is going on. Now, so system 2 is a very quick study. System 2 can adopt an instruction and obey, but it is slow in execution. System 1 is a slow learner, but is fast in execution. So what we call associations between ideas are hard to learn and hard to unlearn. Now, this has important implications for skill, because skilled operations, the operations of what happens with basketball players and with chess players, is skilled performance migrates from system 2 to system 1. It begins as a system 2 operation, and it eventually, when you become skilled, you no longer have the scaffold of remembering the rules. You just do it. Okay. Now, another characteristic of these two modes of thinking, and I've already mentioned it, intuition is effortless, like perception. Reasoning or system 2 operations are effortful. What do we mean by effortless and effortful? As psychologists, we mean a very simple thing. Mostly, we mean that if an operation is effortful, it will interfere with other operations that are effortful. We have a limited ability to do two difficult things at once. And if we try to do two difficult things at once, performance will suffer, which is not true when we're dealing with System 1 operations. So that is one of the characteristics of System 1. It is effortless. System 2 is effortful. And there is an important function of System 2, which this example will show. So you can follow along. A bat and a ball together cost $1.10. The bat costs $1 more than the ball. How much does the ball cost? Now, let me make a prediction. Every one of you, I would think, has thought of a number, and the number is 10 cents. That's been in everybody's mind. Now that makes the problem interesting, because 10 cents is false. You know, if it were 10 cents and then the bat would be $1 more, it would be $1.10, and $1.10 and 10 cents would be $1.20, so 10 cents is not the answer. But now, what is interesting is when you put that question to Princeton students, half of them say 10 cents. Now, and they do even when you give them time. And they don't when you frighten them. That is, you know, when they're really worried about making a mistake, they don't. But otherwise they do. You know, even 45% of students at MIT make the mistakes. So what we learn about people who make this mistake is that they haven't checked. One of the functions of System 2 is to monitor System 1. That is, we don't say everything that comes to mind. We say only a fraction of what comes to our mind, sometimes too much. But we do monitor ourselves. The monitoring, however, is very casual. And this example illustrates how casual the monitoring is. It illustrates, you know, that, well, you know, that number comes to mind and it looks plausible, and it is plausible. It's about $1 less. And out it goes. That is, it turns out, very important. And if you keep people busy, if you, for example, load their memory with stuff so that they have to remember a 7-digit number while doing something else, then I wouldn't say that their behavior collapses, but their behavior changes in an interesting way. So, for example, they will become much less politically correct. So people who are holding a 7-digit number in their head use words that are not quite so nice. They use lady, they use girl, whereas, you know, otherwise they would use woman and sort of be more attuned to with what they're supposed to do. People who hold a 7-digit number in their head are more selfish than if they don't. So System 2 does monitor System 1, and when you interfere with the ability of System 2 to monitor System 1, performance changes. There are shades of Freudian psychology here, but this is the modern version of Freudian psychology. Now, and finally, associative versus rule-governed. That is, and I'll illustrate in a minute what I mean by associative. But I want to describe the mind as a machine for jumping to conclusions. This is when we get very fast answers to complicated questions. We're jumping to conclusions. And that is a very important function of the mind. And whether we do it skillfully or not is a separate question, whether we do it accurately or not. But it's important that this is what we do. Let me illustrate that.